to you, but you have to remember what they mean, what each and every letter represents. And this one, E to RT. So these are the models. This one is for n times per year, and this is for continuous. So we read the problem now. Let's go back. And it reads, use the compound interest formulas of round answers to the nearest cent. Okay, we always do that. Find the cumulative value of an investment of $20,000, which means the principal is $20,000 for 4 years. So T equals 4 years. If 4%, 4.5% per year, so R equals 0.045. We cannot use percent in the formula. We have to change it into a decimal. If the money, number one, is compounded semi-annually, which means n equals 2, is compounded quarterly, which means a equals 4. Part C, monthly, which means n equals 12. And part D, continuously. Okay, so I copied down the information. And what I recommend is, for these three, we use the following formula. I'm going to write A equals 20,000. 1 plus the interest is 0.045 annual interest rate per year. And divide by, instead of putting these numbers one at a time, I'm going to use the graphing calculator. I'm going to consider that x. I have t, which is 4, but n is our x. So I'm going to put 4x. Why do I use x? Only to remind you that the calculator doesn't have n. So in y equals, you can repeat the calculation 3 times. You don't have to do this, but I want to show you a different way. So in y equals, at the top, y equals, put in 20,000, close the open a parenthesis, 1 plus, 0.045, divide by x. X is right here next to alpha. Right here, this is x. Close the parenthesis, put the caret, which is power, and in parentheses, 4x.
Where's x again?
Next to alpha. Yeah. It's in next to green. We have a green key, which is alpha, the one next to it on the right. Yes?
Yes.
Okay, so if you don't want to create this function, what will you do is, you will replace this by 2 and this by 2, calculate once, and then this by 4 and this by 4, and calculate the second time, and this by 12 and this by 12. But as I said, I want to show you a different way. And now, go to second and table set. Second and table set. Scroll all the way down and highlight just this. Do not change that. Just highlight the independent variable and to change it into the ask mode. So down, down, right, and press enter. Now the calculator will allow you to put in the x values that you want. Do we have this so far?
Where's table set?
It's right here in the second one with the key, with the yellow key or the second key, second.
Okay, that's it.
And then scroll down to the right and press enter on the independent only the independent in the ask mode. The dependent has to stay in the auto mode. And now let's go to second and table set, the rightmost. So second and table set right here. And now punch in what we want. And we want 2, 4, and 12. So press 2 and enter, 4 and enter, 12 and enter, and you'll get the answers right away. You don't have to repeat the calculation 3 times. And that happened only because you put in a function in y equals, you created a function, and now you're evaluating the function for different values of x. In this case, it's different values of n, but still the same thing. So Now be careful because we are asked to present the answer with sets. So please scroll to the right and highlight the first number and read what you see here. Go to the top, to the right, and to the top. And let's copy. Now we see the entire number. So we will copy 23,886.62. So the first one, A of 2, 23,896.62. A of 4. Scroll down to the next one, 23,920 and 30. 23920.30. And the last one, highlight that. And A of 12, 23936.29. Now, with the last one, there is no need to create a function because it's only one calculation. So we will have 20,000 E, so second and natural log. And in parentheses, we have 0.045 multiplied by 4 years. 4. Close the parenthesis. So this is the number that we get when the interest is, the accumulated value when the interest is compounded continuously. So A in this case is 944.35. Everyone okay? Bob, did you get those? You need help?
I can figure it out. I'll take too much class time to figure it out.
No. What do you mean?
Somehow my table got messed up and I didn't get the right lines in the table.
No, let's see the function. It's 0.045, that's why. So 5, and it's divided by x, right?
Yeah.
And then close the parenthesis, and then the caret, and that's 4. I will put it in parentheses. Maybe these new sophisticated calculators don't need that, but it doesn't do that. Okay, so let's see now. Let's see if we get to the same thing. Second on table. Yeah. So now it's fine. Now, in order to determine second and quit, in order to show the other one, so you get 20,000, and then second and E right here with natural log, I would personally always put in parentheses 0.045 and multiply by 4 years, close the parenthesis, and then press enter. And we get the same thing, to 23,944.35. Yeah, you just by mistake you missed the division. I do that too. It's okay. Okay, so that was one type of problem that I wanted you to see, and I think there is, let me see what else is in here.
That sounds so weird. Like it sounds like.
Suppose that you have 13,000 to invest. Which of the two rates will yield the larger amount in 1 year? So here we're asked to compare two different situations. So let's compare those situations. I take notes first. So we invest $13,000 and for 1 year. So T equals 1 year. And we have 9% compounded quarterly, which means N equals 4, and 8.92% compounded continuously. Again, the formulas will be given to you. Okay, 13,000. Oops, I'm sorry, I didn't switch. So I have two scenarios. We invest 13,000 for 1 year at compounded and 4 times a year with 9%. There is no point now in creating a function. It's not a repetitive calculation. This is one calculation. This is a totally different one, right? So A equals 13,000 in parentheses 1 plus, remember, 0.09 divided by 4 raised to 4 times 1, N times 1. The other calculation will be 13,000 times E, to 0.0892 times 1. This is the interest rate now, and times 1 because it's 1 year. You can omit this, of course, because it's 1. So now let's put these two in the graphing calculator. So we have 13,000 in parentheses 1 plus 0.09 divided by 4. Close the parenthesis. And then we put the power, caret. I personally always put the power in parentheses, so the power is 4. 4 times 1, there is no need to put the 1. And I get this. The other possibility for the continuous, the rate is different. Second in E, in parentheses, please, 0.0892, I believe, yes. Times 1, so there is no need to do anything else, and just press enter. So the first option gives us 14,210.08, and the second one, 14,212.89. Anyone needs help with the calculator? Bob?
I'm good. Thank you.
Do you have to find all the 3 ways or just the same thing?
No, the second problem is different. We only have 2. The second problem has nothing to do with the previous situation. The second problem only has, by comparison, interest compounded 4 times a year at 9%, and interest compounded continuously at 8.92%. That's why here I used 8.92% and 4 times a year, 0.09. So these are 2 separate. We don't have to, it's not a repetitive calculation, so I don't have to create a function. You don't have to create a function at all. But then you're going to have to, in the previous problem, you're going to have to perform the same calculation 3 times. Which is fine. You're going to get the same answer. Is that okay? Okay. So let's go back to finishing up this. Is there anything else? Okay, so let's look at last problem here. The function, I'm going to copy it. So f of x equals 70e to negative 0.4x plus 30. Describes the percentage of information f of x. So I have to write that down. F of x, percentage of info. So I don't forget what these variables represent. That a particular person remembers x weeks after learning the information. So x is in weeks. So it's time, of course, in weeks. Okay. Substitute 0 for x, and without using a calculator, find the percentage. Okay, substitute 1 for x and find the percentage. Find the percentage of information that is remembered after 8 weeks. Find the percentage of information that is remembered after 1 year. This is a repetitive calculation. It will be always wise to create a function. And then plug in it. 0 we can do by hand. But plug in 1, plug in 8, and plug in 52. Instead of repeating the calculation 3 times. So first of all, let's plug in 0. Let's do this together. How much is 0 times negative 0.4? Perfect. How much is e raised to 0? Excellent. How much is 1 times 70? How much is 70 plus 30? 100, right? Yes. So f of 0 is for 0 weeks is 100%. Now, in order to find f of 1, f of 8, and f of 52, I will not perform the calculation step by step. I will put everything in the calculator. So let's do just that. Let's go back to y equals. Very important to understand this procedure because it saves you a lot of time, especially on a test. Okay. So clear if you have anything else in there. And we put in 70. E. Raise your hand if you need help, please. Negative 0.4x. Close the parenthesis. Make sure that you come down from the power and put plus 30. So So 70 e to negative 0.4x come down from the power plus 30. Let me know when we have this in y equals. And if you do, don't wait for me. Just go to second and table.
So when you do that, you don't need to press enter or anything, just automatically.
Yes.
As long as it's sitting there, it's entered.
It's sitting there, you have the function, so now you go to second and table. Second and table. And table. Plug in the numbers you want. 1 enter, 8 enter, 52 enter. Done. And copy the numbers. So second and table. 1 enter, 8 enter, 52 enter, and I'm done. And these are the percentages. So f of 1 is 76.9%. Just make sure that you put in the numbers as they want it. Let me see what they want. Round to 1 decimal place. Okay, got it. So 76.9, 32.9, and 30%. Do we understand how useful this is? Did you get the function in there?
Yeah.
Did you get the numbers?
I got like all of them.
Excellent. Well done. Any questions? Bob, did you get the numbers?
I did. So you can see that's going to be like a declining number.
Right. So
Some
you
of
understand
it-
it saves us time.
Yes.
You can perform the calculation 3 times. But why? If I have the option of putting the function in there, as you said, it's sitting in there, I'm calling the function and I plug in the numbers. Okay?
Can we go back and see the word problem?
You mean this?
The word problem.
Sorry, this?
Yeah.
Is this the one? Yes. And it's done. We answered all questions. Is that okay? Good. So now this was 34. Let's move on to uh, 36. Okay, write the equation in its equivalent exponential form. How do I write this in exponential form? So we have 4 equals log base 6 of 1,296. Remember how we do this? 6 raised to this power equals this number. It's better to rearrange it because this is how we discussed it, and I don't want you to get confused. Counterclockwise, 6 raised to the 4th power equals 1296. And you can check that it's true. Please remember that. Okay. The next one is the same. B raised to the 2nd power equals 16. Now, here we are given an exponential equation and we're asked to change it into a log. So we have 4 squared equals 16. So be careful now. This looks slightly more difficult, but it's not. So I know I have to have a log. I know I'm expecting a base. I know I have to have a number here, and I have to have something here. And look what we did by comparison. 6 raised to the 4th power is this. So therefore, look here and tell me what is the base.
4.
To which power do I raise 4 to?
2.
To get what number? That's it. So all you have to do, what I recommend, just write this as you would expect from to change it from a log to an exponential, and just identify counterclockwise, remember? But keep the log on the left-hand side at all times. So you can use this idea. Because if you keep it on the right, like here, it's not counterclockwise. It goes the other way, right? So be careful. So always keep it on the left, and you will think in terms of 6 raised to the 4th power equals this. 4 raised to the 2nd power equals 16. Yes?
So if you, the equation you have 4 squared equals 16. Any of those numbers could be replaced by x,
Yes,
and then you can still solve for a logarithm.
yes, of course. Yes. That's how we create the log equations and exponential equations. Okay, so for example, this one, yes, they are trying to trick us. The square root of x equals 2. Not a big deal, right? The square root of x, the square root of 4, sorry. The square root of 4 equals 2. And this is the same with 4 raised to which power? We discussed last time again that the radical is what power? Any radical is a power. What kind? How will I replace this with 4 raised to a power? Which power? 1/2, right? Please don't forget that. So a radical is always a power, but the power is a fraction. It's not an integer, right? Is that clear? This 4 to 1/2 is the square root of 4, correct?
Yes.
Good. So rewriting this in this form, now I can write the log. What is the base?
Yeah. 4.
What do I raise it to? One half. Do I get? 2. 4 raised to 1/2 is 2. 4 raised to the second power is 16. 6 raised to the fourth is this. Okay? Better? Okay. So let's see what else is here.
Those get easier the more than you do.
Right, right. Like almost everything, right? The more you practice. Okay. Find the exact value of this. So let's find one. Log base 3 of 27. Log base 3 of 27. I have no idea what this is, but I know that I can change it into an exponential equation very easily. How? 3 raised to this power equals 27. Exactly what we just did. 3 raised to some number equals 27. Yes. So then what power can it be? There is only one number. No, that's why I said it's not division. Raised to which power is 27? Indeed, it's 3. So then the answer is 3. 3 raised to the third power is 27. Careful, okay? Is that better? Yes? Okay. Moving on. Same thing. 3 raised to which power is 1/3? That's -1. Same thing. 9 raised to what power is the square root of 9? 1/2. 9 raised to 1/2 is the square root of 9. Right? Is that clear? Bob?
Yes.
Okay.
So you could rewrite that as log base. What's the base?
No, I will. So yes, let's write this. Okay. So log base 9 of the square root of 9 is unknown, but I know that 9 raised to a power, unknown power, equals the square root of 9. What can I have here? And there is only one number that fits in there. And the number must be? Indeed. Only 9 raised to 1/2 is the square root of 9. Correct? Perfect. Moving on. Same thing here. We can evaluate the expression here without a calculator. So 4 raised to which power is 2? 4 raised to which power is 2? 1/2, right? 4 raised to 1/2 is 2. Square root of 4 is 2. Do you want me to write this one? Yes? Okay. So they're all the same. So try to remember log base 4 of 2 is unknown. So this is equivalent to 4 raised to which power is 2. And this must be 1/2. Because only 4. Sorry. So log base 4 of 2 is a number. This is equivalent to 4 raised to a power equals 2. What can the power be? It must be 1/2. Only 4 raised to 1/2 is 2. Yes? Yes? Okay. Okay, same thing. 7 raised to what power is 1? 0. 7 raised to 0 is 1. Yes? Is that okay?
So basically what you're doing is you're setting that log base 7, 1 equal to x and solve for x.
Yes. By saying 7 raised to which power is 1. Exactly. Okay. Okay. Graph 4 to the x and log base 4 of x. So we should do this. So we're graphing two inverse functions, 4 to the x and log base 4 of x. 4 to the x is an exponential function. Is it increasing on all its domain or decreasing on all its domain? Excellent. And you will cross at 0, 1. So this is 4 to the x. Remember, it's 1 to 1. We must graph no matter what my MATLAB says. I have to graph y equals x. And all I have to do now, just reverse the coordinates. So this is log base 4 of x. So when you go back and research, obviously this is wrong. Obviously this is totally wrong. Obviously this is totally wrong. Right? And this must be the one. I don't like the graph.
It's not very pretty.
Oh, first of all, it's wrong. It shows here that the graph starts overlapping with the y-axis. That's not possible. Like here, like it's overlapping with the y-axis. I'm sorry, with the x-axis. Of course not. But yes, that's the one we have to choose, although it's not correct, 100%. Okay. Find the domain, yes. So we're given a log function, f of x equals log 3 minus x. How do I find the domain of this function? So what do I write? I have to write something and solve it. I cannot just come up with the answer. I have to write that 3 minus x is greater than 0. Without writing this, I will not be able to determine the domain. I know that this quantity that log is applied to must be a positive number. That's my starting point. I have to write that 3 minus x is positive. And then I have to solve for x. I move 3 to the other side. What do I do next? Right, and I have to switch the inequality symbol. So the domain of this function is negative infinity to 3. Is that clear? Okay, let's look at another example like this. I'm sure there must be another. No, there isn't, but we can make one up. Here it is. Okay. So log base 4 of x plus 6. So this is another log function. Can anyone tell us how I start? What do I write first?
X plus 6 is greater than 0.
Absolutely. That is the starting point. X plus 6 greater than 0, x greater than negative 6, domain negative 6 to infinity, done. Absolutely. Is this okay? Moving on. Okay, so please remember the domain of a log function. We haven't gone into these properties. These have to be reviewed in the next course. You just punch in the numbers in the calculator. We can do any of these that you want. So let's calculate. We have not discussed these properties. They're not part of this course, but they selected them as problems. But let me show you one any. So I'm going to copy. So it's 10 raised to log 34. Okay, so let's do that with the calculator together. Okay, here it is. Get out of there with second and quit. Every time you want to get out of a viewing window, you press second and quit. Second and quit. And now we want to calculate 10. Don't forget to put the caret, which is the power. And then you copy log 34. This is a property of the log functions, but we haven't discussed it. So when you hit enter, you have to get 34. So let's hit enter. And we get 34. Did we get 34?
Yes.
Okay. So then the same thing with natural log of e to the fourth power. You just use natural log this time. All these will be done with the calculator. I would not put a problem like this anyway, because you will learn the properties in the next course. Okay, match the function with its graph. So let's think about this graph for a moment before we select. Natural log of x plus 2. So f of x, natural log of x plus 2. Can anyone tell us how do I write, what do I have to write in order to find the domain of this function? Excellent. So if the domain is -2 to infinity, then the graph has to have a -2 vertical asymptote. We haven't discussed asymptotes, of course, not in this course. So anyway, so if I see a graph to the left of -2, I'll say, oops, it cannot be it. Secondly, is this function, what is its base? What is the base of ln? E. What is the base of log? 10. We don't write these bases though. And we saw that in the calculator, we have those keys. So is this, because it's base greater than 1, will the log be an increasing function or decreasing function? When the base is greater than 1, it's always increasing. So normally the graph of the log is this, but we have to shift it to the left. So this will be natural log of x plus 2. So when we go back to the graphing calculator and the options, you will say immediately no. You will immediately say no, the domain must be -2 to infinity. No, domain is not -2 to infinity, and domain is not -2 to infinity. So obviously, this is the only one. They do not show the vertical asymptote, which is wrong. So it's part A. Okay. The last two are word problems, and I would like to work on those word problems from this section. So let's take a look. The percentage of adult height attained by girls who are X years old can be modeled by the given function. I take notes. X is the age between 5 and 15. So I copy X between 5 and 15, the age, and I copy f of x as 62 plus 35 log x minus 4. Okay, so I have those. I go back, I read again. Represents a percentage of her adult height. Okay, use the formula to determine approximately what percentage of her adult height a girl has already attained at the age of 13. So f of x gives the percentage of the adult height. The function is only valid between 5 and 15, the age of 5 and the age of 15. And we're asked to determine what percentage of her adult height this particular girl will attain at 13. So what do I have to write? What do I have to calculate? What do you think? Of the function where, when x is, that's it. Exactly it. So let's do this together. So f of 13 equals 62 plus 35 log of 13 minus 4. Ready?
The table there with the units were, and then inches,
Percentage.
or percentage.
Percentage, yes. Percentage. So now let's calculate, because we can do this by hand. 62 plus 35 log, in parentheses, of course, 13 minus, you don't have to do that, or you can just put 9. Okay, and press enter. So apparently, at the age of 13, a girl already attains 95.4% of her maximum possible height that she will attain in her life. So f of 13, 95.4%. She will still grow a little, but by the age of 13, she would have reached 95.4% of her adult height.
So
Okay.
If this is valid, it means that they collected data. And
Yes, and they created the model.
model curve fit.
Yes. Will you find outliers? Of course.
Of course, yeah.
It's not going to be valid for everyone. Very good, of course. Okay. So 26. Okay, we have a model here. The loudness level of a sound, D, in decibels is given by this formula. So let's copy it down. You see how many applications of log functions? So D equals 10 log applied to 10 raised to 12 power multiplied by I, uppercase I, where I is the intensity of the sound in watts per squared meter. Decibel levels range from 0, a barely audible sound, to 160, a sound resulting in a ruptured eardrum. The sound of a certain animal can be heard 500 miles away, reaching an intensity of 6.6 times 10 to the 5th, which is D, watts per meter squared. Determine the decibel level of this sound. The intensity, this is the intensity. This is I. Determine the decibel level of this sound. At close range, can the sound of the animal rupture the human eardrum? I don't know what is the, I guess 160 will rupture an eardrum, yes. Okay, so we want to determine D, knowing that I is 6.6 times 10 to the 5th. If the result is above 160, we should not come near that animal. We will be deaf after hearing his cry. Okay, ready? So we have D equals 10 log 10 to the 12th times 6.6 times 10 to the 5th. Okay, so let's try and simplify a little bit. So this will be 10 log 10 to the 12th times 10 to the 5th. I copy the base. And what happens to the exponents? Yes. Okay. So let's see how we put this in. This is not easy to put in. I haven't shown you that, so you may know how. So let's put this in the calculator. So we have 10 log 6.6 times, here's how we put 10. Let me check a second and see if, yes. So go to second key and the comma. And that put 17. close the parenthesis. Do we know where this E is? Second and comma. And this means 6.6 times 10 raised to the 17th power. And now let's press enter and see if it's above 160. If it's above 160, we're in trouble. We should not be near the animal. And it is above 160. It's 178.20 decibels. So let's see how they want the answer. Oh, that's not what I meant to do. I meant to go back to this. Okay, round to the nearest whole number is needed. Okay, in that case, I'm going to say 172. How do I put that? Okay. 178. Okay, and now it's decibels because it's D. I is the intensity. Okay. Okay, so it was 178.
That's one out of animal.
Yeah, I have no idea what type of animal, but pretty intense. Okay, so 38 now. Let me see how I am with the time here. I'm still okay. Add the polynomials. We don't have issues with that. We don't have any problems. We don't know. So what is I again?
That's square root of -1.
Perfect. What is I squared? -1. Excellent. Good. Okay, we know how to add complex numbers. We know how to subtract. Yes? Do we need an addition of complex numbers, subtraction of complex numbers? Yes? Yes? Anyone? Yes. This one?
Yeah.
Okay, so let's look at the difference. 2 plus 3i. Subtract 7 minus 5i. We have to combine like terms. Distribute 2 plus 3i minus 7 plus 5i. Is this okay? And then first the real part, and then the imaginary part. And that's it. Okay. Then another subtraction of complex numbers, another subtraction, a product. These are polynomials. Okay. Do we need to multiply to complex numbers? Yes? The FOIL, but also I squared is -1. So let's do one. Let's do one of those. So -5 plus 7i and 7 plus I. So yes, we use FOIL. So -35 and then minus 5i and then plus 49i and then plus 7i times I, which is 7i squared, but this has to be replaced by -1. So -7 with minus 35, -42. 49i with -5i is positive 42i. I'm sorry, 44, sorry. 49 minus 5. Is this okay? Yes? Okay. Another product, another product, another product. Okay, how do we square? Let's also think about this one. 7 plus 8i squared. Seven plus 8i squared. Remember, we have to get three terms. The first term squared plus 2 times the first times the second. If you need time to calculate, just write it like this first. 2 times 7 times 8i and plus 64i squared, which needs to be replaced by -1. So how much is 14 times 8? I got 112. So then 49 plus 112i and minus 64. So 49 minus 64 is, what is it, negative 15? Correct me if I'm wrong, plus 112i. So this is the way we square a complex number. Any questions? Is this okay? Okay, good. So what is the conjugate of 3 minus 4i?
3 plus 4.
Perfect. Okay, so now I would like us to choose two complex numbers to divide. Okay, what about this one? So let's divide 2 plus I by 6 plus 2i. What do we need to do in order to divide two complex numbers? So we multiply and divide by the complex conjugate. If we have 6 plus 2i in the denominator, we need the 6 minus 2i because we are using the difference of squares formula. So when we square the first term, we get 36. When we square the second term, we get 4i squared. But the numerator has to be FOILed. We have no choice here. So 2 times 6, 12. 2 times negative 2i minus 4i. 6 times I plus 6i. Positive I times negative 2i is negative 2i squared. This has to be replaced. This has to be replaced. Both have to be replaced by negative 1. So then, negative 2 times negative 1 is positive 2 plus 12 is 14, and this is plus 2i. This changes into negative 1 times negative 4 is 4, plus 36 is 40. So then 14 over 40, you have to simplify it, you have to separate it, plus 2 over 40i. Negative 2 times negative 1 is positive 2 plus 2 over 14. I'd rather go back and check. Maybe you see something I don't. And then 6i minus 4i is 2i. Negative 1 times negative 4 is 4. 4 plus 36 is 40. So now I simplify by 2 and I get 7 over 20. I simplify by 2 and I get 1 over 20i. And this has to be the final form. The real part plus the imaginary part. Any questions? Bob, is that okay?
That's good.
Okay. So now let's look at a problem like this. Very important. So we discussed this last week. The square root of negative 36 minus the square root of negative 16. Okay, so let's take a look. Well, the square root of negative 36, remember, is the square root of negative 1 times the square root of 36. The square root of negative 16 is square root of negative 1 times the square root of 16. So then, this is 6 and this is I. So 6i minus, this is 4 and this is I. So the answer is 2i. Is this okay? Okay, let's go back and see what else is in here. Again, how will I change this? I will change it into negative 2 plus what? Maybe you can see, so let me write it. So this is negative 2 plus the square root of negative 16, everything squared. It's a complex number. When I square it, I'm still going to get a complex number. But first I have to simplify it inside before I square. But it's the square root of negative 16. So how do I change that? Negative 2 plus what? Yes, times? Yeah, the square root, yes, yes. Okay, so what will that be replaced by then? Times? Exactly. So 4i squared, and now I square the first term, minus 2 times the first times the second, 16i plus 16i squared. This has to be replaced by? Good. So negative 16 plus 4, negative 12 minus 16i. Any questions? Is it okay? Yes? Okay, so the next ones are pretty similar. Let's also look at one with a ratio. Let's see what else is in here. This is a product. That's good enough. We know how to. If we know how to, that's good. Okay, so let's look at one with a ratio. This one. So in this one we have negative 20 plus the square root of negative 50 divided by 60. So we're asked to fully simplify this. I can do anything to negative 20 for now, and 60 is 60, but I have to simplify this. So I have the square root of negative 50, which is the square root of negative 1, times the square root of 25, times the square root of 2. So 50 is 25 times 2. Why? Because 25 is a perfect square and 2 is not. So then this will be replaced by, and this will be replaced by 5. So I go back and I write negative 20 plus 5i, the square root of 2. 5i, the square root of 2 divided by 60. And now I have to separate it. Negative 20 over 60 plus 5i, the square root of 2 over 60. And I must simplify. The first one gets simplified by 20. So I have negative 1/3. And here I simplify by 5, and I get 12. So plus I, the square root of 2 over 12. And that's the fully simplified form. Questions? Is it okay? I hope you're going to review all this for Monday, right? Yes?
And we have a test on Monday.
Yes?
That was